going to see a problem from electrostatics. You can see the question. The question is the electric field components in the given figure are Ex is equal to alpha x raised to 1 by 2, Ey is equal to 0 and Ez is equal to 0. So means that the electric field is along x direction. Ex equal to alpha x raised to 1 by 2, where alpha has a value 800 Newton per coulomb meter raised to minus 2. Meter raised to minus 1 by 2. Okay. Calculate the electric flux through the cube and electric charge within the cube. A means the side length of the cube is 0.1 meters. So in figure you can see this x direction, y direction is the direction. There is a cube placed. Each side of the cube is A. What is the value of A? A is equal to 0.1 meters. So the cube is placed such that there are 6 faces for the cube. You can see this face and opposite face. These two faces are perpendicular to x-axis. Okay, means these two faces are parallel to y-z plane. And what's the direction of electric field here? The electric field also in the x direction. There's a direction electric field. So direction electric field is along x direction. X direction. So the electric field lines will pass through two faces because only two faces are perpendicular to the x direction. So through these two faces the electric field will pass through. What about the other 4 faces? 1, 2, 3 and 4 faces. Means these 4 faces are parallel to the x direction. So the field lines will never pass through them. So what's our aim? We need to find the electric flux. So what we need to consider, we need to consider these two faces. I'll just shade these two faces. So this is one of the face and this is the other face. Okay. So through these two faces the electric field lines will pass through. Now from origin the cube is placed at a distance A. After distance A the cube is placed. Okay. Now so I'll just draw the side view of the cube, not the 3-dimensional view. This is a cube. Yes, draw one side of the cube. This face I am drawing here. Okay. Now I'll draw the area vectors. Area vector is always perpendicular to the area outward. So there are two faces. I'll draw these two faces. This is one face. Okay. So for this face, this is area vector. These are the area vectors. We will mark ds, vector ds. This is also vector ds. So this is the left side. I'll say L. This is the right side. For left side, area vector is directed towards left side. Okay, to this direction means negative x direction. This is the direction. The area vector at the left side is along minus x direction. Along the right side, the area vector is towards the positive x direction. Okay. So now what is the value area? Means side length is 0.1. A is the side length. A is 0.1. What is the area? I can say ds value of the area is equal to a square. It is a square is equal to 0.1 into 0.1. So it will have a value 0.01. So the area vector on both the surfaces, for the left face and right face, area vector has the same value, but the direction is opposite. Okay. But electric field for both the faces, through both faces, electric field is passing along positive x direction. We need to flex. We need to find the flux at the left side and right side. So at the left side, we can write the equation for flux phi L. We can write. What is the equation of flux? Flux is equal to, we'll use the equation electric field at the left side EL dot the area vector. Area vector means dsL we can write. Area vector on the left side. Okay. Area vector on the left side. Now, what is electric field at the left side? Left side means this from here to here at this point. But the electric field has equation alpha x raised to 1 by 2. X is a position. So, what is this position? From origin, it is at a distance A. So at the position of x, I have to give a. Okay, a means 0.1. So alpha is a constant, alpha is 800. So alpha, I will write instead of alpha 800. For x, at this position, x is having a value 0.1. So I will write 0.1, x into 0.1 raised to 1 by 2. This is EL. Okay. Now what is ds? ds having a value 0.01. So into 0.01. This is the ds. Now we need to take dot product. Electric field at this phase is towards the right side. Area vector is towards left side. Okay. So electric field, for electric field we can give direction I cap because it is along positive x direction. But the area vector is towards left side. We have to give minus x dash and minus I cap. So we need to take dot product. So what will be dot product? I vector I dot minus I vector. So this will be minus. Why it is minus? Because area vector is towards left side. Now we need to simplify this. One more thing. What is the area? Area is 0.01. Okay. Now this is the flux at the left side. We can calculate the value. Before calculating, we will find the flux at right side also. Flux at right side. The same equation we can use. Electric field at the right side. ER dot DSR. This is the area vector. What is electric field at right side? We know that electric field varies with x. Right side, this is the phase. This phase is at a distance a plus a, 2a. So this phase, right phase is at a distance a plus a, 2a. Okay. So we know that electric field depends on distance. So what will be electric field? 800 into, this is alpha. What is x? For this phase, x is equal to 2a. 2a means, a means 0.1. So 0.1 into 2, we will write 2 into 0.1 raised to 1 by 2. This is the difference between these two equations. Okay. Here only 0.1 because the surface at a distance a from the origin. Here the surface at a distance 2a from a plus a, 2a from the origin. So 2 into 0.1 raised to 1 by 2. Now area. Area has same value, that is 0.01 into. Now here for the right phase, the area vector is towards right side. Then electric field also towards right side. Okay. So both in same direction, I can take I dot I. Okay. I dot I. So further simplifying, you will get what is phi L. Phi L is equal to, phi L has got a value. There will be minus 800 into 0.1 raised to 1 by 2. Then 0.1 square, that is 0.01. Okay, this is phi L. And what is phi R? At the right side, this is the flux. So what is the equation? Minus, not minus, it is plus 800 into 2 into 0.1 is 0.2. So 0.2 raised to 1 by 2. Then we will have a 0.01. Okay. Now we need to find the net flux. So what is net flux? Phi is equal to phi L plus phi R. We need to add these two to get net flux. So when we add these two, there are many common terms. Which are the common terms? 800 is common. 0.01 is common. So inside bracket we will have here we have a 0.2 raised to 1 by 2. This 0.2 raised to 1 by 2. Here we have minus 0.1 raised to 1 by 2. Okay. So when you evaluate this, when you take the square root of these two numbers, you will get the answer. When you simplify, you can simplify easily. 800 into 0.01 is, it will be 8. Okay. So you will get 8 into 0.2 raised to 1 by 2 minus 0.1 raised to 1 by 2. So the value, resulting value, when you take the square root, the resulting value will be 1.048. This is the actual value when you calculate. Newton meter square by Coulomb is a unit. This is for electric flux. This is a total flux. Now we have one more calculation. We need to find the total charge within the cube, because charge will be producing electric flux. Okay. So by Gauss's law, if this is a flux, a total flux coming out of a closed surface. We know that by Gauss's law, what is charge enclosed? Charge is equal to, we have the equation for charge is equal to flux, a total flux into epsilon 0. Okay. This is total flux. 1.048 into, what is epsilon 0? 8.85 into 10 raised to minus 12. So when you calculate this, you will get 9.3 into 10 raised to minus 12 coulomb. This is the total charge. Okay, total charge corresponding to this flux. This is the value. So the calculation is over. So we have drawn two diagrams. So actual diagram and a side diagram to make the idea clear. Okay. So this is the cube. These two faces, the left side and right face. Through these two faces only electric flux pass, because electric field is along x direction. These two faces are perpendicular to the electric field. So area vectors will be either parallel or anti-parallel. What about these four faces? The top face, bottom face, and these two faces. These two faces are parallel to the electric field direction. So flux passes only these two faces. What about this face? This face at a distance A from the origin. So electric field also varies. Electric field will have value. We can say alpha A raised to 1 by 2. So this is alpha. A is 0.1 raised to 1 by 2. Okay. This is area vector. Area, the value of area, surface area of one of the faces. Now for this side, for the second surface, for the right surface at a distance A, then one more A we need to add. This is A and this is A plus A, at a distance of 2A. So 2 into A. Then why it is I dot I here? This is the direction of the area vector, rightward. Electric field also in the same direction. And for this phase, electric field is in the same direction, but area vector is opposite direction. That's why you have used I dot minus A. It is clear in this picture. Okay. So these are the area vectors, and this is the direction of what? Electric field. But one thing you have to remember, the electric field is varying according to x. So whenever the value of x changes, electric field. So the electric field at each and every point will be different. Okay, it will increase according to the value of x. So here at this point, electric field is alpha A raised to 1 by 2. Here it will be alpha 2A raised to 1 by 2. That's the difference. Okay, so we have made both the calculations. We have got total flux and total charge due to the flux. Okay, bye.